Hey knuckleheads, here we go again. We're looking at power and radical functions. We're going to look at functions that are in the simplest form, ax to the n, which means that we're looking at information given to us by the coefficient and information given to us by the exponent. Okay? If we have the exponent first, if it's an odd number, we have a function in its base form that looks like this. All right? Positive means it goes upward from left to right. Negative, it means it goes downward from left to right. And we check out our positive and negatives right here with our coefficient. We'll talk about domain and range in a second. If it's an even function, even functions turn out to be parabolas in their base form, ax to the n. So no matter what, if that exponent is even, it's some sort of parabola. We'll talk about bumps and turns later on. Don't worry about it. But for right now, a positive coefficient gives me an upward parabola. A negative coefficient gives me a downward parabola. Let's talk about domain and range. Domain for an odd function is infinity on both sides. Range, same thing. Infinite in both directions. For an even function, domain, infinite in both directions. And for the range, wherever that base form is, most likely at the origin, 0 to positive infinity for a positive function, 0 to negative infinity for a negative function. You can look at n behaviors. For an odd function, it goes infinitely upward, infinitely downward. For an even function, both are pointing straight up or straight down. You can figure that out. In terms of continuity, both of these are continuous functions, right? You don't have to lift up your pencil to get to the rest of the function. All right, we're going to move on. We're going to take a look at some quick examples. We're going to be able to sketch these things, or else you're going to use your calculator to help you draw. I'm going to scroll down. These two functions, if you use a calculator, it's going to be real simple. This one's super simple. It's an even function. It's pretty narrow because of that positive 3 right here. Keeps it pretty tight. Stretches it upward. That's a parabola. That should be easy to do. Here's our problem. If we rewrite this with a positive exponent, I have 1 over 5x to the third. All right? You would think of that as an odd function. Our problem is our x is in the denominator. Therefore, we're going to have a vertical and horizontal asymptote. So if we start talking about the n behaviors, the n behavior here is increasing. It's trying to get to 0, but it never gets there. If we talk about the n behavior over here, it's decreasing. It's trying to get to 0, but it never gets there because we have a numerator of 1. So it'll never actually get to 0. Here, 0 doesn't exist. That's why we have that asymptote, because you can never divide by 0. It doesn't exist. Now we'll move to the second part of this show, which is solving radical equations. I'll prepare another video for that.